All right, Module 3.1, Lesson 1, we're going to look at solving quadratic equations by graphing, which, thanks to technology, is easy. All right, solving equations, quadratic equations by graphing. First of all, a quadratic equation in one variable can be written in this form, where a, b, and c are real numbers, and a can't be 0, because if a was 0, then you wouldn't have this quadratic term, and it would be a linear function, and what's the point of life at that? I mean, come on. Is that too far? Did I go too far? I apologize. But if a was 0, you wouldn't have a quadratic, and that's why a can't be 0, because we're talking about quadratics. Come on now. A root. Here's a vocabulary word for you. Root of an equation is a solution to the equation, and if you want to talk about that in graphing terms, it's also called the x-intercept. So root, solution, x-intercept, those are all the same thing. All right, so to solve a quadratic equation by graphing, you just find the x-intercepts of the related function. If you're doing ax squared plus bx plus c equals 0, then you find the x-intercepts of y equals ax squared plus bx plus c. This we can graph with a graphing calculator. And when y is 0, think about where y is 0. Above the x-axis, y is positive. Below the x-axis, y is negative. But right on the x-axis, y equals 0. So on the graph, wherever the graph touches here, the x-axis is where y equals 0. And now if this is a 0, then you have the same as what you got up here. So x-intercepts. So here are a couple of examples that we are going to solve by graphing. Let's take a look at this first one first. X squared minus x minus 6 equals 0. So I am going to graph the function y equals x squared minus x minus 6. And to do that, I'm going to use my beloved Desmos.com/calculator, and I'm just going to push in x squared minus x minus 6, and look at that graph. Same graph as this. So you notice that the x values of our x-intercepts are x equals -2 and x equals 3. Now here's something interesting that you can do with this super awesome calculator. If you were to take this, I'm just copying and pasting, and put equals 0, look what it does. It solves it for you. X can be -2 or 3. Just like it says right here, -2 or 3. Cool beans. So the x-intercepts are -2 and 3. So the solutions or roots are x equals -2 and x equals 3. See, that was not too bad because the calculator did most of the work for us. Here's another one. Now remember, it has to be ax squared plus bx plus c equals 0 so that we can graph y equals ax squared plus bx plus c. But this is not in that format. We need to get an equals 0. So if I subtract 4x from both sides, I'm going to get, on the right side, 4x minus 4x is 0. On the left side, now you might be like, oh, do I subtract it from the -2? Do I subtract it from the -2x squared? And the answer is no. Neither one, because none of them are like terms. So we just have to write it out in descending order. Remember that from polynomials? -2x squared minus 4x minus 2. So what I'm going to graph is y equals -2x squared minus 4x minus 2. So I'm going to put this guy in my calculator. So it looks like the only x-intercept it has is at -1. So x equals -1. Don't be tricked by that, because y isn't 0 right there, right? We're only solving this quadratic equation when y is 0. Now here's a trick that you could do. If we were just type this in the way it's written up there, in the problem anyway, look what this magical calculator does for us. Solves for x. Tells me x is -1. Just like the picture. So when I graph this quadratic function, I get this graph right here, x equals -1, is my solution. So the solution, or root, or x-intercept, is x equals -1. And now, folks, it's time for some practice. Holla!